In this student example, we're going to come across an issue that's going to require us to use an additional formula to be able to solve this one. We're determining the surface area of a triangular prism, which is composed of 2 right triangles and 3 rectangles. So I'm going to draw these figures. And I'm just going to draw 3 rectangles, kind of how they would be. And I'm going to also label my right triangles. So we can see that we have a right angle, and base and height are always projected from a right angle. So we're good here. We have a 40 by 30 height of our triangle. So we have 2 of those. And then when we look at our rectangles, this is where we come into some difficulty. We can see that the one in the back is a length of 40, and the height is the same all the way around. So this is 45 over here and 45 over here. So that's all good. So we have a rectangle which is 40 by 45. And then when we look at the side one, this kind of smaller rectangle that we can see, we have a side length of 30 and a height or a side length of 45. So I'm going to label that one over here. It's the front one that's going to cause us some difficulty. For the front one, we don't have this side right here. So the very top side that I'm marking in dark black, that side is missing. We don't know that one. We do know that the other side is 45. So how are we going to get this missing side length? The way we're going to do this is to use a theorem called Pythagoras' theorem. And you may have seen this in your previous studies. Pythagoras' theorem is for right triangles where we have 2 shorter sides and we have a hypotenuse. And a hypotenuse is the one that's directly across from your right angle. And that hypotenuse is indicated usually by the variable c. So we have a formula on your formula sheet that says c squared is equal to a squared plus b squared. And we're going to need to use that formula in order to calculate that missing side. So c squared is equal to one of the sides, let's say 40 squared, plus the other side, which is 30 squared. And a and b, it doesn't matter which sides you assign. They're just a and b. So c squared is equal to 1,600 plus 900, which is 2,500. And then what we have to do there is we have to take, pardon me, we have to take the square root of that. So we now need to take the square root to get the side length. And so c is equal to 50. So now that we know that that missing side length is 50, we can label and solve the area of that last rectangle. Okay, so now we can do our triangles. We have 2 of them times the base times height divided by 2, plus we have our rectangles, length times width, and we have 3 different rectangles that we need to find the areas of. So let's start to solve. So for our triangles, we're going to take 2 multiplied to 40 times 30 divided by 2. So I'm going to cancel here. 40 times 30 is 1,200. We don't know what the units are, so this is just going to be squared units. We can leave that blank for now. So those are our triangles. And then for our rectangles, we're going to have 45 times 40 plus 45 times 50 plus 30 times 45. Okay, so we can solve each of these. 45 times 40 is 1,800. 45 times 50 is 2,250. And 30 times 45 is 1,350. So those are all of our rectangle areas, plus the triangle areas, and we can put all of that together. So 1,800 plus 2,250 plus 1,350 plus 1,200 gives us a total of 6,600. And because we don't know if this is meters, centimeters, inches, whatever it is, we're going to indicate that we have some kind of units and that these are squared units because it's all area. This is a big problem, but you will face these sometimes where you need to calculate a side length using Pythagorean theorem in order to be able to solve for surface area. I hope you found this example helpful.